Hi guys, for today's lesson we're going to be dealing with enlargement and similar figures. So what do I mean by a similar figure? Well, it's two shapes which have the same shape, so they look the same, they have the same shape, or i.e. all angles match, but they have different size. So i.e. One of them is the enlarged version or maybe the shrunken version of the other. So for example, if you look at this shape right here, we've enlarged it to this shape here. Notice that this dot here, this point here, A, corresponds to this point here on our bigger triangle. That's why we have A and A dash. A dash is what we consider to be the image of another point. So this A has changed to this one. This is pretty much the enlarged version of this point, if that makes sense. This is our similarity statement. We're pretty much saying that this triangle here, triangle ABC, is similar to, that's the symbol for is similar to, triangle A dash B dash C dash. So pretty much what we've got here with these red lines is pretty much the way that you can make these similar triangles. So we pretty much draw any shape we want, and then we pick a point near it, and from this point we draw lines to each corner of our shape, and we extend these lines. We keep these lines going, and the idea is if we try to copy this sort of shape over here inside these red lines, and you just want to make sure that each line is parallel to each other, they've got the same slope. So like that line is parallel to that line, and that line is parallel to that line, etc. You will make a similar shape. So you could have chosen to make one here. If we try to keep them parallel, those lines, it would work. Okay, so next up is the scale factor. The scale factor is a multiplier that describes the degree of enlargement or shrinkage. So the bigger the scale factor, the bigger the enlargement, and if the scale factor is smaller, it suggests it's going to be shrinking. Scale factors are always positive, by the way. So for example, with this one here, when this triangle got enlarged to that one, what was the scale factor? Well, the idea was like this length here, AB, this changed to this length here, which became 6 centimeters. So like 3 centimeters changes to 6 centimeters. The idea, it was multiplied by 2. So that suggests our scale factor is 2. That's like the multiplier. How this length changed to this length, it was times by 2. That also happened to, for example, that length there, AC, that was 5 centimeters, and it changed to 10 centimeters over here. So that was also multiplied by 2. All these side lengths have to be multiplied by the same number to get these lengths over here. Another thing to notice is that like OA, so the length from here to here, that was say 10 centimeters. The length from O to A dash also is doubled, so it became 20 centimeters. So literally, if you've got a scale factor of 2, everything is just going to be doubled, if that makes sense, for this triangle here. It's doubled in size, if that makes sense. Okay, so the formula to figure out this scale factor is to pretty much take the image length, so the lengths applied to this triangle, and divide it by the lengths applied to this triangle, the original lengths. Okay, so let's just do some examples for scale factor. So if you look at these two triangles, it went from this triangle to down to this triangle. Notice that we pretty much took these points and we shrunk them down by going to one particular point. And so we got this triangle here. You'll notice that this length of 8 centimeters has now changed to 4 centimeters. This is our original, that's our image. So we do image over the original, and our scale factor is 1/2. So this is pretty much half the size. Over here, this triangle got enlarged to this triangle. You can see that 4 centimeters changed to 10 centimeters. So therefore, it's image over the original, which is 10 over 4, which equals 2.5. That is our scale factor. Note that scale factors between 1 and 0 suggest shrinking, and scale factors greater than 1 suggest enlargement. Okay, so let's do some example questions. So given that the following shapes are similar, so we know that they're the same shape but just different sizes, find the value of each pronumeral. So we know these lengths, we know this length and this length. That should be enough information to figure out X and Y. The idea is to find the scale factor. Similar shapes will always have a scale factor. And we find the scale factor by using 2 matching given side lengths. and then we multiply and divide by our scale factor to find these pronumerals, because we can see that 20 matches with x. So if we know the scale factor here, we can just divide by the scale factor to get our smaller value of x. So let's do that. So here we can see that that this 4 centimeters matches with this 15. So we do image over the original. So 15 divided by 4. Our scale factor is 3.75. To figure out our y matches with this side right here. So 3.75 is going to be multiplied by our scale factor. So 3.75 multiplied by our side length of 3.5. That gives us a y value of 13.25. This length here would be 13.25 centimeters. Next up, to find x matches with this 20 centimeters. To go from the image back to the original, instead of multiplying, you would want to do the opposite, which is divide, and you would get a length of 5.3 repeater centimeters. So that's our values for x and y. Let's do another one. This is a little bit harder. So you can see we've got a triangle here and a really big triangle. Those two triangles are similar, and they've given us some lengths for this triangle. This is enough information to figure out what our x is. So the idea is you do want to split this diagram up into the 2 original triangles, which you can see. Looking at them separately is a lot easier to deal with. So we can see that our 4 centimeter side here changes to a 10 centimeter side. So it's going to be 10 over 4 for the scale factor, which equals 2.5. If we want to find this length here, we've got to take this matching length and multiply it by that scale factor. So the idea is that this side is going to be equal to 3 centimeters multiplied by this. So that side length of x plus 3 is equal to 3 multiplied by our scale factor, 3 times 2.5. So we get x plus 3 is equal to 7.5. X must therefore be equal to 4.5. So that's the length from there. That's the length of that x there. Hope this helps with the questions. Good luck.